Hello everybody. In this episode, we are going to be exporting and submitting files to PCB Way so we can get our first pilot run. I don't even know if you'd call that pilot. It's like an alpha run of the board that we've been designing to see if everything actually works with all of the components installed. So I'm going to walk you through how we're going to do that. I've actually never done it in PCB Way through the online way that I'm going to show you here in a second, because I've always just sent the Gerber files to the person that emailed me originally about using PCB Way, and then she would enter the order. I tried that and she said submit it online. So apparently we're done with the concierge service and I have to submit it through the online site like a regular person now. And so I want to show you how we do that. And yeah, I'll learn as we go, because like I said, I've never done it that way before. So let's first of all bring up where we are keeping all of our files. And so I've got this fab. I'm gonna delete everything that's in this folder because we're gonna do it again from scratch. So I've got this empty fab folder underneath my EDA folder, and this is where I'm going to output all of the files. So let's come out over to here. What I'm going to do is show you, we finished our bill of materials. If you'll recall, we bring this up, you can see everything has a part number, so we're ready to submit that. And so, but to submit the files for them to make it, they have to fab it, which means create the printed circuit board as well as assemble it. And so we need to give them files so that they know how to do that. And so we'll close this out. And what we'll do for that is we need to actually go into the PCB view, which is here. I've got the front and back copper turned off just to help with visualizing things. And what we're going to do is we're not going to output specifically the silkscreen layer. And that's all these things like R15, R13, R18, C16, all this stuff, because I want to know that the board works with how everything is laid out first before I take the time to move all of these silkscreen designators all over the board so it looks nice and pretty. I don't really care about that now. I'm just testing functionality and making sure that they can make the board, assemble it, and that everything works as I expect it. If it doesn't, and we need to make changes, if we take all the time to like neatly put all of the silkscreen markers where they're supposed to go and resize them and make the whole thing pretty, and then we have to move a bunch of stuff, that's just a bunch of wasted time. And so I'm not going to put that time in now. We're just going to submit it, get 5 of these back, and see how they work. And so in our PCB view here, the first thing we're going to do is we're going to go to File, Plot, and you'll notice I have deselected the silkscreen layers, the front silkscreen and the back silkscreen. Once we confirm the design, we'll move everything around and then we'll add those layers back in. But for right now, we're going to leave them unchecked. And then I didn't really change anything else in here because, to be perfectly honest, I don't know what to change these things to. This is, again, not my strong suit, and so we're going to figure it out and learn as we go. So I'm going to just leave everything as it is. The output directory is fab, and then I'm just going to go ahead and hit plot, and you'll see if we come back, that just generated a whole bunch of Gerber files for the different layers. And then I can also generate the drill files. Again, I left everything just as default. I don't know if it's helpful to have the plated through hole and non-plated through holes in a single file. These are things that after I submit it, if they say, hey, could you do that? We can come back in and mess with these settings. I have all the units in millimeters. And so that's it. I'm going to say generate drill file. You can see it created a main PTH and a main NPTH drill file, again, in this same folder. It's these two down here at the bottom. Which is great. So we'll close that. We've got those files. The next thing they're going to need is a pick and place file to know where the machine that does the assembly is supposed to place all of the components. And so for that, I believe we come here to File, Fabrication Outputs. There's a footprint position file. And again, defaults, because I don't know any better. And now this separate file is for front and back. I don't know that matters because I have no parts on the back. Well, that's not entirely true. The JST for the batteries on the back, but that's a hand solder, so the pick and place machine won't do that. So we'll generate the position file. And you'll see that in here, main top position, main bottom position. Like I said, I don't, the main bottom, there's not really anything that the pick and place machine will do there. And so we've got that. What am I missing? Is that everything? Oh, and we need to send them the bill of materials. So this big giant list that we created back here, right here, that is, you know, C1 is this part number, C2, 11, and 21 is this part number. We need to give that to them as well so that they can source the components. And so we'll cancel out of here. And KiCad has this little bomb generator. It's really cool, and it's got some different options that you can choose from to generate it. This will generate an XML file, which then you can do whatever you want with, which I think is really cool as a from a programmer perspective. But then it can also transform that into other things, and so you'll see that it'll even tell you what the command line is that it's going to run down here, which I think is really cool. And so I want this bomb2 grouped CSV, and I'm going to hit generate, and it'll say success, it's generated, and it puts that back up here in the EDA, this main with no extension. If I open this with LibreOffice Calc and hit OK, you'll see that I have everything in here and all the parts. We got to scroll a little bit. There we go. There's all the part numbers that they can order. And so that's great. We're going to say file, save as, and we're going to save this as main. Let's save it in the fab folder with everything else. Main.csv. I guess that's a format that they can read it in. I don't know. Again, we're going to submit this, and if it's not what they need, they'll get back to us. They have people review the files, and they'll tell us what we've done wrong, and that's how we learn. We'll just push through. Okay, so that's the bill of materials. I think that's everything. We've got main CSV, and then all the Gerbers and the position files and the drill files. I think that's everything. And so what we're going to do is, I've already got it open over here. I'm going to drag this over to this screen. I'm here on PCBWay. I'm logged in. Now, as you go through this PCB specification selection, this is just to give you a rough price. You still have to submit the files, but they just base it off of a couple of things like the size and the quantity and the layers. Let's just go through these really quickly. So the board type, single pieces. Panel by customer means if you want 10 of these and you want them on a single PCB panel that you can break apart, you have to design that on your end, or you can do panel by PCBWay. They'll do this automatically when you order a bunch. Like when I ordered 100 of my puck products, they panelized it for me because it's easier and faster for them to have it panelized, not only to create the printed circuit boards, but also to do the assembly. And so for now, we're doing a run of 5 as a test. We're going to select single pieces, different design in panel. It's just the one design. The rough size is 43 by 53 millimeters. We want to do 5 pieces. 5. The layers, it's a 2-layer board, front and back, nothing more complicated than that. The material we want is FR4. This is just very standard. We want TG130. I actually have no idea what that means. That's just what I've done on all my previous runs. So that's probably something that I should learn and figure out, but I don't. I just do TG130, 140. The thickness is 0.8 millimeters. This is crucial for my design specifically because I need a really thin board. I don't have the case with me right now, so it'll fit in the case properly. The minimum track spacing, remember we did 6 mils and 6 mils when we were doing our layout. Minimum hole size, we did a minimum of 3 mil. The solder mask, I thought red would be really cool. Match the Maker Crew logo there. The silk screen can be white. Again, there's not going to be any silk screen on this first run because we're just testing function. There are no gold fingers on it. That's like the edge fingers like you would have on like a PCI card. So we don't have any of those, so that's a no. Surface finish, again, I'm not sure on this. I looked at a previous order that I ran for my pucks, and I selected immersion gold 1U. I mean, I guess you could do, I wouldn't do with lead. I'd always do lead free. So let's just see what the price changes to. Oh, well, see, that's cheaper. Hazel lead free. I mean, maybe we'll do that for the run and forget about the immersion gold. that we might change Hazel to Enig at our discretion. Yeah, whatever. Okay, let's just see how that goes. That took off almost 25 bucks. You can see the price over here. It's not cheap to do these small runs. It gets much more affordable. Like when you do a run of 100 of these, so if I'm doing 5 at 127, you know, that's over $25 a board. Am I doing that right? That's about $25 a board. When you do a run of 100, they're like 99 cents a PCB. So that price gets a lot better with volume very quickly. Tenting vias, what this means is that when they do a via, remember when we jump from the top side of the board to the bottom side of the board and it's plated all the way through, tenting means they're going to pour the solder mask right across it and cover it up. So there won't be any exposed pad. Like if you want to do a test point with a meter or something, it'll be completely covered and non-accessible. If you say via is not covered, then it'll leave that copper exposed so that you can use it as test points. Tenting vias is fine for me. I don't need any of those vias to be untented. And so it gives it a little bit of a cooler look, I think, because it covers up all the holes that you have everywhere. Finished copper, 2 ounce. Again, you can see the little image here. This is just how thick you want that copper to be. That can play a role in how much current you have going through some of your traces. 2 ounces is what I've used in the past, so we'll use that again. And not to add extra PCB product number. Yeah, I don't need any of that. So it's going to be 127 just for the fabrication. And then this is as far as I've made it. Assembly service, I am going to check yes. And so here I was explaining earlier, there's a couple of options. You've got turnkey, which means PCBWay will source all the parts for you and assemble it. You've got kitted or consigned, which means I buy all the parts, ship them to me, so I'm paying shipping to get all the parts to me, and then I got to pay to ship them all to China. That gets really, really expensive, especially when you're doing low quantity like I am. I did that for one of the runs that I did on my pucks, and it was crazy expensive to ship it to China. And if it gets lost, good luck. Like, this isn't the United Postal Service, not that there's like a shining standard of global delivery, but at least you can call them up and say, hey, where's my package? Did you lose it? If that thing gets lost in China, which has happened, not on parts, I sent something else to somebody in China, never arrived, it's gone forever. You're never going to see it again. And so if you bought hundreds of dollars of parts and then paid $150 to ship it to China, and then PCBWay says we never received it, you're out of luck. So I prefer the turnkey. They source it. The downside and the argument against turnkey is that, and I personally haven't experienced this, but knockoffs. So I'm going to give them a list of parts that I want specifically. And if those parts are unavailable, they've said, hey, we can't get those parts, pick another one. But depending on who you go through and use as your turnkey service, they might just say, you know what, a 10K resistor is a 10K resistor. We've got some right here. We'll use them. And so you can't guarantee what you get, that the part numbers are the part numbers. Because like those little teeny 0402 resistors don't have model numbers on them. You can't inspect them and say, oh, that's the 13-digit model number that I wanted. It just looks like the right thing. And so that's the trade-off. The combo, I actually did combo on an order as well, where I supplied particle P1 modules, but they supplied everything else. Again, shipping to China is going to kill you. Board type, single pieces is how I would like them. Assembly side is the top side because, like I said, there's nothing on the bottom. Well, I guess it is both sides. You know what? Let's do top side. I can solder on the bottom side. That might save us a little bit of money, so they don't have to. It's just a JST connector. So for this, I'll solder those on. We'll just do top side. Quantity. Fill in total quantity of single PCBs, 5. Stencil, yes, I need them to stencil it. Stencil is they create a cutout of all the footprints on a piece of, sometimes it's a Captain, is it called Captain tape? They'll use a thin sheet of metal, which allows them to use that to lay down solder paste on your board so that they can stick the machine will stick the components in the solder paste, reflow it. And so you do need a stencil. Sometimes they'll let you provide your own stencil. Number of unique parts. I would have to look back at this. 34, looks like 33 unique parts on mine. So we'll say 33 unique parts. Or leave it blanked away. It's 33. Number of SMT parts. The total number of SMDs on each board, including fine, pitch, and leadless. So total parts. Let's see if KiCad will tell us that. We've got, I'm sure KiCad can give us like the total part count. I'd be surprised if it didn't. Basically, we want to add up all the quantities here. And so I know I don't have to do that by hand. Like, let's see, quantity. You know what? Let's just save ourselves some time. And right here, right here, we'll say equals. And we'll say sum of B2 to B34. I think that's how you do it. 72. All right, 72 unique parts on our board. So we'll say 72. Number of through-hole parts. We'll say 0 because we'll do it ourselves. We only have, well, through-hole parts. Yeah, the only through-hole part is the JST connector. So we'll say 0. And additional options. Depanel the boards to delivery. No. Function test. No. Firmware loading. Nope. Conformal coding. No. Okay. Let's hit calculate. All right. Looks like $138. So, wait, what am I missing here? Did this not break out in between? Assembly service price is $6 a piece. Shipping, I don't know why they charge me separate shipping. Okay, so here's the cost. This is crazy. Like this assembly cost is insane. Okay, so if you can see this, sorry if it's a little small on screen. The PCB cost is $113. The assembly cost is not $220 apparently. It's just $30, which $220 even would be insane. Like insanely cheap. I mean, I had some of these done stateside. The price was astronomical. It was crazy. And the quality was terrible. They sucked. Half of them didn't work. And so assembly is $30. That's crazy. And so my total is $138. That's just for the fab and assembly. I still have to pay the price of the parts, which they'll send me a quote on after they figure out. I'm going to have to give them, I'm assuming at some point here, they're going to ask me for the list of parts, which we'll put in. And so I guess we just add to cart. Like, I don't know. This thing pops up relentlessly. Like, I'm afraid to click it. Like, account balance 5 can be used directly for order payment. Is added into your account. Please check my account balance later. Okay, great. Fine. They gave me $5. Under review. So I still like, they've got to have the files, right? Okay, right here. File not uploaded. There we go. Okay. So shopping cart order review. Here's my 2 layers. Red solder mask, white, PCB assembly. $30. I still can't get over that. That's crazy. Okay, so for the assembly, let's add, okay, only 7-zip CSV they'll take. We do not accept BOM files in PDF. Oh, I was thinking about exporting to PDF, so I'm glad I looked at it. Centroid file and other. See, I don't know what a centroid file is. Like, is that the position file? I think that is the position file. And I don't know what format were those in. Position.pos. Like, that doesn't. Yeah, so I don't know. Let's click on centroid template file. So it looks like that. What does our position file look like? Open with text editor. That's the bottom. There's nothing on the bottom, so let's look at the top one. Does not look like that. It's got ref and designator. Okay, I'm not. It's got all the positioning. Well, we'll just see. I don't know. Let's upload the BOM. I mean, we can do that. Home devs, Navigator hardware, DA fab. Okay, main CSV. So let's open that. Did it get it? Eagle version 7 Gerber file. No, I don't want to do that. I'm gonna have to think about this. Let's close that out. Let's do add file here. It's gonna ask me the same thing. So let's do. Okay, let's simplify all this. Instead of figuring this out, let's just wrap up fab the whole directory. So let's do compress to zip, and we'll call it stat feeder pilot fab. I don't know. That sounds good. Got a nice ring to it. All right. We'll just upload the whole thing like that. There it goes. I saw it make a little uploady thing. Partless BOM. Let's give it main CSV. Okay, and then say, oh, right here. Jeez, I'm not even paying attention. All right, so it's got that. And okay. And we'll just say submit order, I guess. I don't have an Eagle 7.7, so let's just do submit order. And I'm sure that they are going to get back to me and say something is not right. While we wait on that, let's just do a quick Centroid file keycad. How to generate the Centroid file. Let's just... Oh, come on, Centroid. It might have been the format that we did. So let's just check that really quick, and then we'll call the video, because we've submitted it, and if it's wrong, they'll get back to me, and then I'll make another video about what we did wrong, and we'll fix it. But let's come back to KiCad really quickly and do file. Let's close this. Do file. Oh, we got to be in the PCB view. Over here. File. Oh, I didn't save, so hopefully that's okay. Fabrication outputs. Position file. Format. CSV is maybe what we needed it to be. Nah, I don't know. We'll let it go for now, and we'll see what they get back with. And say footprint report. RBT. Yeah, I think we're good. All right. So that's how we submit our files. Like I said, we'll see what they get back to. It's actually, I'm filming this in the evening, so it's like workday over in China. I think there might be holiday right now there, actually. So we'll see when it comes back. And when it comes back, I will make another video explaining, you know, hey, it went through and they're working on it, or we had to make some adjustments. And so we'll go from there. It looks like it's going to cost us, you know, under 150 bucks to do 5 of these, which is really great. That might seem expensive, but to get fully assembled boards, that's a pretty good deal. So that's going to do it for this episode. I appreciate you watching and hope you'll tune in next time.